interested in pressure. That means force acting per unit area. That means total change in momentum in 1 second. So I got एक बार collide होएगा तो change in momentum 2mc1 आएगा. So if it collides in 1 second 2 times, then what will be change in momentum? If it collides 1, we got 2mc1. We want in 1 second. So I'm saying suppose in 1 second it collides 2 times, then it will be into 2.
Yes, sir.
3 times into
2
3.
mc1.
No, 2 mc1 is when it collides once, na?
Yes, yes, yes. But into
So
2 is 4 mc1.
4.
Yes.
So into 2, 3 times into 3, 4 times into 4, x times into x. So my now target is to find in 1 second, one molecule will collide with wall how many number of times? If I get x, I will multiply 2mc1 into x. If I get 4, 2mc1 into 4. Have you followed?
Yes, sir.
Okay, just listen. If this molecule starts from this phase, goes to this phase, it has covered distance L. Again, when it comes back, it will again cover distance L. So can I say when it covers distance 2L, that means it is successive collision?
Yes, sir.
मतलब इधर से स्टार्ट किया 0 वाला, तो एक बार कोलाइड करने के लिए 12 डिस्टेंस कवर करता है ना वो फिर से. तो ऐसा अगर वो 10 बार कोलाइड हुआ तो मुझे समझ जाएगा कि 12 डिस्टेंस में 10 बार. एक लॉजिक वापस समझो क्या बोल रहा हूँ. In 12 distance it collides 1. We are interested in 1 second में कितना बार कोलाइड हुआ. तो 1 सेकेंड में कितना डिस्टेंस कवर करेगा दैट आई एम फाइंडिंग ना. 12 डिस्टेंस पे एक बार कोलाइड, 1 सेकेंड का डिस्टेंस पे कितना बार कोलाइड. बाय यूनिटरी मेथड आई कैन फाइंड. सो कैन आई राइट लाइक दिस, इन 12 डिस्टेंस number of collision equal to 1. So in C1 distance, what will be number of collision? Twelve distance, 1 collision. C1 distance, how many collision? Can I say C1 upon 12?
Yes, sir.
Okay. But ये C1 मीटर पर सेकेंड स्पीड है ना वो सिंगल मॉलिक्यूल का.
Yes, sir.
तो C1 मीटर मतलब 1 सेकेंड में डिस्टेंस कवर किया है ना उसने. सो ये C1 डिस्टेंस मतलब वी कैन से दैट फॉर इन 1 सेकेंड. मतलब यही चीज अपना 1 सेकेंड वाला है. नंबर ऑफ कोलिजन इज C1 अपॉन 2L. C1 distance covered in 1 second. So in 1 second, number of collision is C1 upon 2L. Any doubt till this? This is only difficult part in this derivation. 2L distance, 1 collision, C1 distance, C1 upon 2L collision. But C1 is the distance covered in 1 second. So in 1 second, number of collision is C1 upon 2L. So I can say therefore, change in momentum due to one molecule in 1 second is 2mc1 into c1 upon 2l collision. That means mc1 square upon l. Clear?
Yes, sir.
Okay. So therefore total change in momentum in 1 second due to n by 3 molecules will be mc1 square first molecule ka change in momentum, mc2 square upon l, last one will be mcn by 3 square upon l. Please copy this much. mc1 square upon L, mc2 square upon L plus dot 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 up to mcn by 3 square upon L. Completed?
Yes, sir.
Okay. Yeah, everybody is completed till last line?
Yes, sir.
Okay.
Yes, sir.
So if you take m by L common, you will get C1 square plus C2 square. Last is Cn by 3 square. Let C be RMS velocity. Therefore, C square is C1 square plus C2 square plus Cn by 3 square upon number of molecules n by 3. So wherever I see this C1 square, C2 square, Cn by 3, can I multiply, write C square into n by 3 then by cross multiplying?
Yes, sir.
So therefore we can say change in momentum in 1 second, that is force exerted, comma, F will be m by L into n by 3 into C square, because change in momentum upon time is called force. So change in momentum upon 1 second is called as force. Now pressure exerted, comma, P is force upon area. So area is L square for one of the side. So it becomes m by L n by 3c square, area L square. So it is 1/3 of mn into c square upon L cube. Therefore pressure is 1/3. Mn upon L cube means density, rho c square. So pressure exerted on the wall of container is given by P equals to 1/3 rho c square. Now copy till end. Pressure exerted, P equals to 1/3 rho C square. Yes, completed for.
Yes, sir.
Last line, right? This is an expression for pressure exerted on the wall of container. This is an expression for pressure exerted on wall of container. Yes, done, correct? Hello, completed?
Yes, sir.
Okay. अभी ये डीएवी का फेवरेट है, इनफैक्ट हर एक का कॉलेज में 2 मार्क का वाला क्वेश्चन. Deduce means obtain. Boyle's law from kinetic theory of gases. That means whatever we proved here, pressure wala formula, from that I have to prove Boyle's law. So from Ktg, that means from kinetic theory of gas, we got P is 1/3 Mn upon volume V into L cube. Density I wrote mass upon volume. Where? Upon rho C square. Mn into C square. Half into Mn upon V, which is density, into C square. Where P equals to pressure exerted, M is mass of each gas molecule. N equals to number of gas molecules. V is volume of gas and C is RMS velocity. So P means pressure, M is mass, N is number of molecule, V is volume, C is RMS velocity. We are interested in Boyle's law. Boyle's law means PV equal to constant. So V I am taking on that side. I am multiplying by 2 and dividing by 2. So 2 by 3 into half MC square into N V I took on that side. What is half MC square? This is called average kinetic energy, correct? M is mass, C is our average velocity. So PV will become 2/3 of average kinetic energy into number of molecules. 2/3 is constant or variable? 2/3 is what? Constant or variable?
Sir, is it constant?
2 is number, 3 is number, so 2/3 is number. N is number of molecule, that is also constant.
Yes.
But what about average kinetic energy? Average kinetic energy is variable but will be constant when temperature is constant.
Yes.
That is our assumption. When temperature is constant. So average kinetic energy will be constant when temperature is constant. So therefore I can say PV becomes constant at constant temperature. Okay.
Yes, sir.
Therefore P is inversely proportional to V. कौन सा law ये? Boyle's law?
Yes, sir.
Last line. This deduces Boyle's law. Copy full. For 2 marks, guaranteed question for every college, those who have done this chapter.
Done, sir.
So last line, right? This deduces Boyle's law. This deduces Boyle's law. Next heading. Show that C is root of 3 RT upon M, or C is root of 3 Kt upon small m. R is called universal gas constant, T is absolute temperature, M is molecular weight. Here K is called Boltzmann constant, M is nothing but molecular weight, mass of each gas molecule. So again from kinetic theory of gases. From kinetic theory of gas, P is 1/3 of Mn upon V into C square. Same history of review. P equals to pressure exerted, M equals to mass of each molecule, N equals to number of gas molecules, V equal to volume of gas, and C equals to RMS velocity. C equals to RMS velocity. Now PV I can write as 1/3 of Mn into C square. For ideal gas, we know that PV will become nRT. Just copy this much.
Done, sir.
Okay. So PV equal to nRT. Wherever I see PV, I can put there nRT. Everybody is done?
Yes, sir.
Okay. So nRT is 1/3 of Mn into C square. What is meaning of N, Arshita? What is N?
Number of gas molecules.
No, it is number of mole of gas. N is number of mole. No?
Yes, sir.
That is nothing but total mass of gas upon molar mass, no? Which is nothing but total mass Mn and molar mass capital M. Okay.
Yes, sir.
So therefore, total mass Mn upon M into RT is 1/3 Mn into C square. Both side Mn I can cancel. So it will become C square equals to 3RT upon molecular weight. Therefore, C is 3RT upon M. That is first what they wanted. So if they show that C is 3 RT by M. You will stop here. Copy it in this. Completed?
Yes, sir.
If they say show that it is proportional to root T, then because 3Rm is constant, we could write C is proportional to root of T. If they ask, then I have written show that it is 3 kT by R upon Avogadro number is called as K, which is Boltzmann's constant. R upon Avogadro number is called as Boltzmann constant. So since 3RT upon molecular weight we proved. So this is 3 times R, mass of one molecule. Molecular weight is total mass of Avogadro number of molecule. So it is nothing but 3 kT by small m. Hence copy. Okay, PNB ना. You check 200 ले लो. और अपना वो IDFC फर्स्ट कम हो उतनी से 60 ना वो 100 ले लो. अच्छा ठीक है ठीक है. Yes, done.
Yes, sir.
Okay. Now, show that kinetic energy per unit volume equals to 3 by 2 P. This is mostly MCQ question. Kinetic energy per unit volume is dash, or at 1 atmospheric pressure kinetic energy per unit volume will be dash. So we have to prove it is 3 by 2 P first. Since from Ktg pressure P is 1/3 Mn upon V into C square, where P equals to M equal to N equal to V equal to C equal to, I am not writing because we have written in previous two theories. So therefore this is P equals to 2 by 3 into half Mn upon V into C square. I multiplied and divided by 2. So 2/3 of half mc square I am taking together into number of molecule into V. 1/3 mc square is called average kinetic energy into number of molecule into V. See, suppose A plus B plus C upon 3 ka average is 10. Then can I say A plus B plus C, that means total is 3 into 10?
Yes, sir.
So what you are doing, average value into number, you multiply, you get always total, na? So average kinetic into number of molecule, when I multiply, it will become total kinetic energy. So just one line more. So kinetic energy upon volume is 3 by 2. Kinetic energy per unit volume is 3 by 2. Copy. Completed?
Yes, sir.
Okay. Note, write down same kinetic energy per unit volume. We can modify in four different forms. Kinetic energy upon volume is 3 by 2p. So that means kinetic energy will become 3 by 2 pv for 1 mole of ideal gas. pv equals to RT. Therefore, kinetic energy for 1 mole is 3 by 2 into RT. Right, one equation extra. Copy it in this. So if they ask kinetic energy for 1 mole, it is 3 by 2 RT. R is universal gas constant and T is called as absolute temperature.
Noted, sir.
Okay. 1 mole means how many molecule? Avogadro number?
Yes, sir.
So I can say, therefore, kinetic energy for Avogadro number is 3 by 2 RT. So kinetic energy for 1 molecule will be 3 by 2 RT upon N. Okay? 3 by 2 RT by Na. This also followed ना? 1
Yes,
मोल
sir.
मतलब Na के लिए इतना, तो 1 के लिए कितना? Divide by Na. What is kinetic energy then for 1 molecule? The same thing. R by Na. Can I write Kt?
Hmm.
R by N is what? K, na?
Yes, sir.
So I can also write, see, kinetic energy per unit volume 3 by 2. Kinetic energy per mole 3 by 2 RT. Kinetic energy per molecule 3 by 2 K. Second equation.
Done, sir.
So kinetic energy per unit volume, kinetic energy 1 mole, kinetic energy 1 molecule we got. Now I am doing kinetic energy for 1 kg. See how to do. Since molecular weight capital M corresponds to Avogadro number. So 1 kg will be how many molecule? Will it be Na upon M molecule?
Yes, sir.
So kinetic energy for 1 kg is energy for one molecule into, which is R upon Na also you can write, into number of molecules present in 1 kg. So it is 3 by 2 RT upon molecular weight. Right. Okay.
Done, sir.
एक बार ये फॉर्मूला को सब मैं लाइन से लिख देता हूँ so that if numerical comes you'll be able to directly write formula. First, kinetic energy per unit volume is equals to 3 by 2 P. Then kinetic energy per mole equals to 3 by 2 RP. Kinetic energy per molecule equals to 3 by 2 RT upon M, RT upon Na, which can be written as 3 by 2 Kt. Then kinetic energy per kg equals to 3 by 2 RT upon Na into Na upon M. So this will get cancelled. That means 3 by 2 RT upon molecular weight. Now see, if you see carefully, if I get 1 mole का आंसर डिवाइड बाय एवोगाड्रो नंबर 1 मॉलिक्यूल मिलेगा, उसको डिवाइड बाय मॉलिक्यूलर वेट करेंगे तो पर केजी मिलेगा. मतलब एक्चुअली एक ही कैलकुलेशन है. फिर डिवाइड बाय एवोगाड्रो पर मॉलिक्यूल, डिवाइड बाय मॉलिक्यूलर वेट पर केजी. राइट दिस अगेन. ABCD चार्ट 4 मार्क्स के लिए दे कैन आस्क इन एग्जाम.
Done, sir.
Sharing, right? Degree of freedom. Degree of freedom. If a molecule is allowed to move only in one axis, along one axis. Then we say its degree of freedom is 1. एक ही लाइन में जा सकता है, like motion in 1D. अगर इसको plane में जाने दिया, then it is called as, it has got 2 degree of freedom. It can go along x, along y, along x, along y, along x, along y. And if it is moving in a space, then it is called 3 degree of freedom. So in simple language, can I say ability of molecules to move is called as degree of freedom? Hello?
Yes, sir.
Suppose it has got ability to move only along x-axis, or only along y-axis, or only along z. How many degree of freedom?
3 degrees, sir.
3. 1 degree of freedom. 3 कैसा? एक ही डायरेक्शन बोला ना आपको?
Oh, okay.
एक ही डायरेक्शन में जा रहा है तो 1 डिग्री ऑफ फ्रीडम. और 2 डायरेक्शन में गया तो
2 degrees of freedom.
और स्पेस में गया तो 3 डिग्री ऑफ फ्रीडम.
3.
तो डिग्री ऑफ फ्रीडम का सिंपल मतलब क्या हो गया? किधर किधर वो जा सकता है ना इजीली.
Yes, sir.
Right. The ability of gas molecules to move in a given direction is called as degree of freedom. Is called as degree of freedom. Next line. If the gas molecule molecules can move only in one direction, then it has 1 degree of freedom. If gas molecules can move in a plane, then it has 2 degree of freedom. Third paragraph. If gas molecules can move in space, then it has 3 degree of freedom. Then it has 3 degree of freedom. Yes, completed?
Yes, sir.
Tomorrow extra lecture same time, okay?